Chapter 11 is all about solutions, homogeneous mixtures. It is easy to think of mixtures as falling into one of two camps, either being homogeneous or being heterogeneous. But as we're learning in all things, there are really kind of degrees and in-between areas. And I want to finish this chapter by looking at that in-between area for mixtures. I want to talk about colloids. Colloids are in that gray area between being a homogeneous and a heterogeneous mixture. Colloids are also referred to as colloidal dispersions, where small particles are dispersed throughout a medium. For colloids, the particles will range in size from a nanometer to a micrometer, or 1 nanometer to 1,000 nanometers. And the particles depend on similar charge to create repulsive forces, and they will be suspended by these electrostatic forces, overcoming any pulls of gravity that might try to separate them. Suspensions are also in that gray area, but in a suspension the particles are a little bit too big, and so given enough time they'll fall out of solution. The easiest way to identify a colloid is to use something called the Tyndall effect, or Willis-Tyndall scattering. Because the particles of a colloid are in that 1 to 1,000 nanometer range, those particles are about the size of the wavelength of visible light. This means that those suspended particles can interact and actually scatter visible light. And so when you shine a light source through a colloid, you will see light scattering. This is why fog machines and smoke machines are used for laser shows, because the fog or smoke is a colloid. And so as the laser beam goes through the colloid, you can see the beam scatter a little bit, and you can actually see the beam traveling through the fog or the smoke. Without the fog or the smoke, you don't see the beam. You only see the dot where the laser is hitting a surface. The Tyndall effect also explains why you can see your headlight beams on a foggy day when you're driving. Because again, the fog is a colloid of water particles suspended in the air, and the beams of light coming from your headlights are scattering as they go through the colloid, and you can actually see the beam traveling through the fog. You can't do that with a homogeneous mixture, and you can't do that with a heterogeneous mixture. Colloids come in all sorts of different phases. You could suspend gases and liquids or gases and solid. You could suspend liquids and gases. You can suspend liquids and liquids. You can suspend liquids and solids, and so on. All of these are different examples of colloids. The last thing to talk about is how to get a colloid no longer be a colloid. How to separate out the solute from the solvent or the suspended particles from the surroundings. And this is a process called coagulation. Generally, if you heat up a colloid enough, just molecular motion alone can get the particles to interact with each other and fall out of solution or fall out of the mixture. Another thing to do is you can introduce an electrolyte. By putting salt in a colloid, for example, you can overcome those electrostatic repulsions that are suspended the particles, and the particles can lump together and fall out.